At some point in your high school education, you probably learned about the difference between an even function and an odd function. So let me remind you that distinction. An even function versus an odd function So the definition of an even function is just a function where f of x is the same thing as f of negative x. Whereas for an odd function, f of x is the negative value. So maybe you can put a negative value of f of negative x. So why are these called even and odd? Well, the reason is because the simplest functions that satisfy this are even and odd polynomials. For example, if I have the polynomial x squared, then if I plug in 2 or negative 2, I get the same thing, right? Or if I have the polynomial x to the 4th, I could plug in 2 or negative 2, and since it's an even power, I end up with both cases the same value. Both will be positive numbers. They're equal to each other, regardless if I plug in a positive or negative number. And likewise for higher evens, x to the 6th and so forth. It's also even true for x to the 0, right? X to the 0, well, that's just constantly 1. So it doesn't matter what you plug in, that one's always the same. By way of contrast, these odd functions are things like x cubed, because if I plug in 2, I would get 8, but if I plug in negative 2, I get the opposite. I get negative 8 when I have an odd power. That negative remains negative. Or if I have x to the 5th, same thing, and so on with other odd powers. And it's even true for just x to the 1, which is just x, right? If I plug in negative x, I get the opposite of if I plug in x. I get the negative of it. Of course, these aren't the only even and odd functions. You have other ones too. Like, let's try and think of some more. Okay, what's a function? How about some trig functions? How about sine? So if you think about sine of a little positive value or sine of a negative value, you could think on your unit circle. If you have your unit circle, sine is the y value. So as you go up, it's positive. As you go down, it's negative. Sine is actually an odd function. So sine of x is down here. It's an odd function. Whereas cosine is an even function. Cosine satisfies this property. You can think about the graphs. Maybe that's helpful. So what do these even graphs look like? When I have these even graphs of things like x squared or x to the 4th, well, those just look like parabolas. But you can also think when I have the graph of something like cosine, well, that also has this nice symmetry with respect to my y-axis. The right-hand side and the left-hand side of the y-axis are symmetric. So you have this symmetry along the y-axis for even functions. A positive number, a negative number, when you plug them in, x or negative x, 3 or negative 3, whatever you're plugging in there, they give you the same value. Whereas for odd functions, what does x cubed look like? Well, x cubed is something like this. When I plug in a number like 2 cubed, it gives me 8, whereas negative 2 cubed gives me negative 8. It's not a symmetry like before. It's a rotational symmetry. It's like 180 degrees rotated to get over here. It's not a mirror image like above. Rather, it's a rotational symmetry. And same thing with sine. When you think about the graph of sine, what does sine look like? Well, sine looks something like, this graph. So, okay, that's not a perfect image, but there's a crude sketch of what sine looks like. He should be going up more. But that has this rotational symmetry to it. As I plug in something like pi over 2, it gives me 1. When I plug in negative pi over 2, I get negative 1, right? So that's the difference between even and odd graphs. And you could think about more trig functions also, like, secant. Secant is just 1 over cosine, so it's also going to be even. Secant is also even. Cosecant is 1 over sine, so that's going to be odd. Cosecant is odd. Cosecant is odd. How about tangent? Maybe this isn't obvious to you. How about something like tangent? Well, you could think of the graph of tangent. Maybe remember the graph of tangent looks kind of like the x cubed graph. Of course, it's squeezed between these asymptotes. But that graph should be suggestive that your tangent graph here has this nice rotational symmetry. So tangent graph, at least between like negative, where is it defined? Negative pi over 2 and pi, that your tangent there is odd. So tangent would be in this family, at least in that domain right there. Okay, so we have even functions, we have odd functions. So what is this good for? Well, this can help us find the definite integral. In particular, if you're trying to calculate the definite integral from minus a to a, so only when it's from minus a to a of some even function, so f of x dx, but we're in the case of f of x is even, then because we have this symmetry, we know the area on, if you're going from, say, like minus a to a, and let's focus on like this function. Okay, we can do either one, but this function. Then notice if we're trying to find this total area from minus a to a, from the symmetry, since it's a mirror image, the total area is just going to be twice the area from 0 to a. From 0 to a of f of x dx. So, maybe this isn't super useful, but it can be a nice little shortcut. So if I'm trying to find something like what is the definite integral from like minus 2 to 2 of even functions. So say it's like, x to the 4th plus 3x squared dx. This is all even because if I plug in negative x into this function, I get the same thing as if I plug x into the function. This shortcut is just telling me that would be the same thing as 2 times the area from 0 to 2 because of the mirror symmetry. So I don't have to go from negative 2 to 2, you just go from 0 to 2. And maybe that becomes a little bit easier to solve because once you find the antiderivative, plugging in 0 is going to be easier than plugging in negative 2. So not a huge time saver, but a small time saver. The more significant observation is for odd functions. Because for odd functions, if you think about what is the correspondence between this area on the right-hand side versus the area on the left-hand side, you have, because it's rotational symmetry, this area on the right-hand side is just the positive of the corresponding negative area on the left-hand side. Like if I focus on just one of these functions, so just one of these functions, and maybe I want to find, some area over here, well, the corresponding area over here on the left is the same but negative. So that is to say, if I'm asked to solve, let's do it in the same color, if I want to find the definite integral from negative a to a of an odd function f of x, then that just will be 0. It's just going to be 0 because it's going to be this much negative area with this much positive area. Those will cancel to give me 0. And so this is a huge time saver, right? Come up with whatever odd function you like. So come up with some odd functions. So let me come up with an odd function for you. Okay, here's an odd function. Any of these would be odd. It's some if any of those is odd. Here's one that maybe doesn't feel odd to you, but it is. Suppose you had sine of x divided by x squared plus 1 dx, and you want to find the area from negative pi to pi. Now, looking at that, it may not be obvious that it's odd, but like take a second to think, what happens when I plug in negative x? When I plug in negative x to this guy, so I'm going to need a little bit of room, so I'll just do it up here. What happens if I plug in negative x? Sine of negative x over negative x squared plus 1. Well, it comes out to be, simplify it, sine is odd. So sine of negative x is negative sine of x. X squared is even, so negative x squared is just x squared plus 1. But when I plug in the negative x, I end up with just the negative of what I had when I had regular x that wasn't negative. So I end up with just a negative sine over x squared plus 1, which means that this function satisfies the definition for being odd. So this overall function is odd. You might say it's a weird combination of even and odd, but what it is actually an even function divided by an odd function, but that comes out itself to be odd. So Here the analogy, even and odd breaks down. Even divided by odd. Odd divided by even comes out to be odd, but that's what it is. We just saw it. It comes out to be an odd function. And so since this is an odd function, since it has this rotational symmetry, the area to the left will just be the negative of the area to the right. And if you don't believe me, graph this out. If you draw the graph, you should be able to see it. That left of the x-axis, it's below, and to the right, it's above the x-axis, and it's symmetric. And so it's symmetric, but negative symmetric. And so this total area is just 0. You don't have to find the antiderivative. You have to do anything fancy. You just know the total will be 0 because these areas will cancel out with each other. So sometimes, when you come up against a problem that seems impossible, it will be helpful to stop and pause for a second and ask, well, is the function even or odd? Especially if it's odd, that might make a function that seems difficult actually trivial. You might be able to just say, it's 0 because it has this kind of symmetry going on here where the areas cancel.